Understanding causal reasoning. In the previous episode, you learned about inductive arguments, where the argument is built on connections or similarities between cases or examples. Causal reasoning is another form of an inductive argument. Causal reasoning is a way we can evaluate several possible explanations to determine which explanation best accounts for the outcome. Often people want to make an argument about why something has happened or whether something is likely to happen. In order to make that kind of an argument, it is necessary to say something about what has caused or is likely to cause a given event or outcome. In this episode, you will learn about the value and purpose of causal reasoning, important questions to consider when engaging in causal reasoning, and how to apply that reasoning. The value and purpose of causal reasoning. Being able to establish what caused what allows people to make many different types of arguments. First, by using causal connections, we can offer explanations of events or outcomes that have occurred. That is, we can answer the question, why did X happen? Second, causal connections can help us make predictions. If we've determined that, at least generally, X causes Y, that is, when X is in place, Y is likely to happen, then we can predict future instances of Y. Finally, establishing causal connections allows us to determine who or what is responsible for a particular event or outcome. Assigning responsibility is important for many reasons. One reason is that if we identify something as a problem that we'd like to address, knowing who or what caused the problem is necessary for dealing with it. If you decide that you want to make sure B never happens again, it's essential to figure out what caused B to happen in the first place. In some cases, engaging in causal reasoning to figure out whether A caused B, or simply what caused B, is fairly easy. If you're watching a tennis match and you see the ball fly over the net to the other side of the court, it's pretty likely that you also see the tennis racket striking the ball, causing it to fly over the net. So when someone asks you, why did the ball move that way? You can respond by referring to the racket strike. But much more often, in the case of the wide range of social, economic, and cultural issues and problems people grapple with, figuring out what caused some outcome or event is very difficult. Let's consider the 2008 economic crisis. Many people are still asking, why did the U.S. economy collapse in 2008? There are many possible explanations and many causal arguments that have been made about that event. Because we do not see the cause and effect relationships in the economic system the same way we do with a tennis racket striking a ball, we have to find ways to make inferences about what we believe happened. Key things to keep in mind. Causal reasoning is frequently part of problem solving for pressing economic and cultural issues. That makes it an important but challenging aspect of critical thinking. There are some key things to keep in mind as you engage in causal reasoning or evaluating the reasoning of others. First, you should be aware of a crucial distinction between correlation and causation. Put simply, correlation occurs when two things tend to happen together. It refers to an association or relationship between the two things. When someone says that A and B are correlated, that means there's some kind of connection between A and B. Perhaps a person who conducted data analysis found that when A was high, B was also high, or that when A decreased, B also decreased. But note that establishing correlations does not say anything about causation. Causation refers to a specific kind of relationship in which one thing is the reason another thing happened. Causation goes beyond simply saying that A and B are related or correlated. It's much more important to critical thinking to claim causality, such as A causes B. For example, consider two aspects of a class that can be measured: grades and attendance. A professor might keep track of attendance throughout the semester, along with, of course, tracking the students' grades. At the end of the semester, he looks at a spreadsheet and notices that students who have high attendance scores also have high grades, whereas students who have attended class infrequently have low grades. he might conclude that attendance and grades are correlated. That is, there's a relationship between attendance and grades. However, based solely on this single premise, when attendance is high, grades are high, and vice versa, he cannot make the argument that regular attendance causes higher grades. The fact that these two factors vary together, when one is high, the other's high, when one's low, the other's low, is not enough to establish a causal relationship between them. One causes the other. The professor would need additional evidence to justify a causal claim about the relationship between attendance and grades. In addition to recognizing the difference between correlation, there's an association, and causation, the association is such that A causes B, you should also recognize that causal relationships involve time and location. Generally, causality involves events that are close in time and location, but that's not always the case. One of the reasons why engaging in causal reasoning in order to make an argument about causation is so difficult is that causes can occur long before and/or far away from their effects. Let's take the 2008 economic crisis again. Whatever the cause or causes of the crisis, it is clearly not the case that something specific happened on day one and then on day two the economy collapsed. Instead, those searching for causes need to go back weeks, months, and even years to sort through what happened and make a causal argument. Another complicating factor is that many events and outcomes can have both direct and indirect causes. A causes B, which causes C, and so on. A direct cause is the event closest in time and/or space to the outcome you're trying to explain. Indirect causes are those things that preceded the direct cause and in some way contribute to the chain of events leading to the final outcome you're concerned with. Take, for example, a large forest fire. The direct cause might have been a lightning strike that hit one tree, causing it to catch on fire. But there may be indirect causes that made that area of forest more susceptible for fire, such that a single tree catching on fire resulted in a very widespread forest fire. Maybe the area had been experiencing a drought, so the trees and undergrowth are really dry. Another important distinction is between necessary causes and sufficient causes. You've already learned about the difference between necessary and sufficient premises. The same distinction applies to causes. A necessary cause is a condition that must exist in order for a certain effect to occur. If A doesn't happen, then B can't happen. A sufficient cause is one that is enough for the effect to occur. A alone is required in order for B to happen. For most complex problems, it's unlikely that any one cause will be sufficient. How do I actually engage in causal reasoning? If cause and effect relationships can be so difficult to recognize, given that the relationship can span time and space, effects can have both direct and indirect causes, and most involve a combination of multiple necessary and/or sufficient causes, how do we actually offer an argument about causality? While the process is rarely easy, there are some basic methods you can use to help you narrow down possible causal factors. First, you can look to figure out what factor seems to always be in place whenever a given outcome or event occurs. This is known as the method of agreement, because you're looking for common features across many instances of a type of occurrence. For example, those looking to explain the 2008 economic crisis might look at past economic crises and depressions to see if there were common themes across all of those events. Remember, know that some things seem to occur along with other things indicates correlation, but does not guarantee causation. But at least you have an idea of where to focus your efforts. Second, you can look for something that is not always present, looking for what factor is in place when event X happens, but not there when event X does not happen. This is known as the method of difference because you're trying to figure out what is different about a situation. What factors were in place leading up to the 2008 economic crisis that were not present, say, during the 1980s economic boom? Third, you can start with correlation. If you observe a phenomenon or conduct analysis on results, such as attendance and grades, and realize that when A changes, B typically changes too, then you've established a correlation. While correlation does not equal causation, it does signify that there is some kind of relationship in place that's worth looking into more closely. With an understanding of the complexity of causal relationships, you can apply these tools to evaluate causal arguments made by others and to form your own causal arguments. There are two main ways that causal arguments are used. First, they are put forth in order to explain a specific event, outcome, or phenomenon. The 2008 economic crisis is just one example of the broad range of social, economic, political, and cultural events that people seek explanations for. Causal reasoning can help us wrestle with different possible explanations to figure out which one seems to best account for the outcome. Causal relationships can help us explain how events are related, but we also want to be able to make predictions and plan for the future. Understanding why the 2008 crisis occurred is useful, but it's especially useful if we can take that explanation and use it to try to prevent such a crisis from occurring again. Causal arguments allow us to understand the relationship between various factors and use that understanding to develop plans and policies to either cause a specific outcome or prevent an outcome. If we can make predictions based on our knowledge of what has happened in the past and why, then we can predict when it'll happen again or change our behavior so that it doesn't happen again. These plans and predictions are only as strong as the causal explanations on which they're based. Causal reasoning is an effective tool for critical thinking. Not only can we say that two events occurred together, we can explain why. In addition, we can take the causal relationships and predict what will happen next time we see the conditions that led to those events.